Hey guys, here's our last section on on working with lateral numbers, dividing lateral numbers. So let's take a look. So when we are dividing lateral numbers, we're going to have to use some tricks. Dividing lateral numbers is just like when we were dividing radicals. It's pretty much identical. And there's a reason for that, which we'll talk about in a minute. So when we're dividing lateral numbers, we have to remember certain conventions, okay? So our answer must be in the form of a plus bi, where a is the real part of the number and bi is the imaginary complex lateral part of the number, obviously because it's got the I in it. So the real part always comes first, the I comes second. And we're going to use that same trick that we used when we were dividing radicals. We multiplied by a factor of 1, okay? And sometimes we just used a radical in both the numerator and the denominator, but sometimes we had to employ multiplying by a factor of 1 using the conjugate. So we're going to do pretty much the same thing here. Okay, so when we're dividing lateral numbers and simplifying, if there's just an I in the denominator with one term that's just got one term with an I in it, then we'll multiply by a factor of 1 using I only. But if there's two terms in the denominator, then we're going to multiply by a factor of 1 using the conjugate. So I don't know if you guys remember, but the conjugate, all you do is, so if we looked here, a plus bi, the conjugate of a plus bi is a minus bi. All you do is switch the sign. And conversely, the conjugate of a minus bi is just a plus bi. So we're either changing the plus to a minus or the minus to a plus. That's all the conjugate is. So let's take a look at that in action so that you guys sort of have a better idea. So if we look at this example, 4 plus 2i divided by 5 minus 3i, because remember, a fraction is just a division problem. Well, we see that we have two terms in the denominator, right? 1, 2, 5, and then minus 3i, which means if we have two terms in the denominator, we're going to multiply by a factor of 1 using the conjugate. So let's look at the denominator. It's 5 minus 3i. Well, what's the conjugate of 5 minus 3i? 5 plus 3i. We need to make that a factor of 1, so whatever is in the denominator goes in the numerator. So we're just going to take our original expression, 4 plus 2i over 5 minus 3i, right here, and multiply it by a factor of 1 using the conjugate. So 5 plus 3i over 5 plus 3i. 5 plus 3i over 5 plus 3i, guys, that's just 1, right? This is just 1. We can always multiply by 1. It doesn't change anything, but it's going to make it look the way we need it to look. And you'll see that as we go through our second example today. So let's take a look at some examples now and work through them together. So here we have 5 divided by 6i, okay? And before we start jumping into dividing and simplifying this, I want to talk about why it's a problem to have that 6i in the denominator. So if you think back to our chapter on radicals, and when we were doing division, we couldn't have a radical in the denominator. Mathematical convention doesn't allow for it. Well, 5 divided by 6i, if you remember what I is the square root of -1, which means I is a radical. So if we have an I in the denominator, we have a radical in the denominator. And by mathematical convention, that's not allowed. We cannot have a radical in the denominator, which is the reason why we can't have an I in the denominator. So that's why when we have these expressions, you look at it and you're like, that's already simplified. It is, but this I is a problem because this I is a radical. So we just can't have a radical in the denominator. We have to get rid of it. So remember I said there's two ways we're going to do that. If there's just one term in the denominator, that means we're multiplying by a factor of 1 using I. So all we're going to do here is multiply by I over I. I over I is 1, right? Anything over itself is a factor of 1. So we're going to take our original expression and we're going to multiply it by this factor of 1 because that's going to get rid of that I. You'll see why in a second. 5 times I, that's 5i. 6i times I, that's 6i squared. Well, what is I squared, you guys? -1. Okay, so 6 times -1, that's -6. So this simplifies down to -5i over 6. And now we no longer have the I in the denominator, so this is no longer a problem. So now this is fully simplified. So let's look at an example that's just a bit more complicated. So here's our second example. We're going to divide and simplify. We automatically realize that this is a problem because there's an I in the denominator, which means we have a radical in the denominator, and mathematics convention doesn't allow for that. So this time we have two terms in the denominator, 1, 2. So we're not going to multiply by a factor of 1 using I. Now we need to employ the use of the conjugate. So we're going to multiply by a factor of 1 using the conjugate of 3 minus 2i. Well, what is the conjugate of 3 minus 2i? Just switch the sign, guys. It's 3 plus 2i. So that means that 3 plus 2i is going in the numerator and the denominator of our factor of 1. So we're taking our original expression, 2 divided by 3 minus 2i, and multiplying it by that factor of 1 using the conjugate. So 3 plus 2i over 3 plus 2i, that's just 1, right? This right here, that's just 1. We can always multiply by a factor of 1. That's never going to change anything, but it is going to help us out in terms of convention. So I want you guys to pause the video and I want you to FOIL this out and see what you get. Okay, so really hit pause, because if you do these examples with me, you will get so much more out of it. And this is a more complicated example. So do the steps, it will help your brain remember them. So hit pause and come back in a second. So I'm hoping you've hit pause and you've FOILed this whole thing out on the bottom and multiplied out on the top. So that's what you should have gotten, okay? 6 plus 4i over 9 minus 6i plus 6i minus 4i squared. And so the reason we multiply by the conjugate, you guys, is it gets rid of that I term, because you'll wind up with a plus of your I term and a minus of the I term, and they'll go away. So that leaves us with 6 plus 4i over 9 minus 4 times negative 1, because remember, I squared is negative 1. If we simplify that down, we get 6 plus 4i. Those negatives cancel, so we get 9 plus 4 on the bottom, which gives us 6 plus 4i over 13. Now remember what I said, you always want your answer in the form of a plus bi. So in order to do that, we need to split this, so it's 6 over 13 plus 4i over 13, okay? Because it has to be in the form, our final answer has to be in the form of a plus bi, okay? So that's why I split it up, because now I have my real number, my a, plus bi, my imaginary complex lateral number. Here's some examples for you guys to give a try on your own. Remember to go back in the video, pause, go through it with me step by step. As I do a step, you do a step for your example, and let me know if you have any questions. And that's it. All right, bye guys.